Hi everyone, I am Guy. I'm working with ProbeLab at Protocol Labs. And lately we've been working on a project that is the effectiveness of the Bitswap discovery process. So we dug into Bitswap. So what was the motivation for this project? So at ProbeLab, we want to get rid of as much magic numbers as we can that are inside IPFS. What's a magic number? So it is just a number that is there, and we don't really know, or we don't have a strong reasoning why it should be this value. And so we're chasing them. And Bitswap in particular, so the way it works is when a user or when an IPFS GET request is made, Bitswap will have 1 second to broadcast requests to all of its connected peers. And if it didn't find the block it's looking for within this 1 second, it will start a DHT lookup to find the content providers and then fetch the data. And so today we want to find out if 1 second is actually a good value. And we will also measure whether or not Bitswap is efficient to discover content in general. In order to be able to reason about this, we had to measure Bitswap and measure the IPFS network. So we had to request a lot of CIDs through Bitswap. We got a big list of CIDs just by sniffing Bitswap traffic on the network. And so the setup of the experiment is we give Bitswap 15 seconds to find and fetch the content, which is a lot. And we prevent it to use the DHT. So it's only Bitswap. You can only broadcast to your directly connected peer. You cannot use the DHT to find the content. And in the case Bitswap doesn't find the content within 15 seconds, we will simply verify on the DHT if the content is available or if just Bitswap couldn't find the content because it doesn't exist anymore. We also want to prevent recursive content resolution, which means that if you get the root CID of a block, we don't want to follow up with other blocks that are inside this file because they're likely stored on the very same host. And we run all of the measurement in a Google Cloud VM in a data center in Central Europe. So that's for to explain the latencies that we will have. So the result we got from these studies is that Bitswap was able to discover content on its own in 98% of the case, which is really a lot. So Bitswap alone can find content. So the price to pay is that Bitswap is really flooding the network. It will solicit more than 800 peers and send like 700 messages. So it will literally flood the network, but it will most of the time get the content it's looking for. So now we can see, so the CIDs we took, we think are representative of the IPFS network requests in general. And so out of roughly 50 requests, actually the top 10 peers provide roughly 60% of all the blocks. So it means that if you're directly connected to only the top 10 providers, you will get a 60% success rate with Bitswap discovery, which is a lot. And it proves that the IPFS network providers are somehow centralized. And so we can see on the right that so the top 10 peers really provide a lot of CIDs, and a lot of them are operated by NFT.storage. So that represents a big share of all the IPFS traffic. So now we're going to look at the latencies. So as we can see, most of the IPFS requests are resolved within 1 second. So the time that is plotted here is both the discovery time and the fetch time. So the time it takes to discover where the block is stored and to fetch the actual block. And so we can see that some of the requests take let's say, more time, let's say up to 9 or 10 seconds, but it's very rare. And if we zoom further inside the first second, we can see that there is a high peak in the 201st millisecond. So we have that almost 80% of the successful Bitswap request return in less than 200 milliseconds. Yeah, so it means that Bitswap is fast, Bitswap finds the content, but Bitswap really floods the network, which doesn't scale, because if the networks would scale 10x or 100x, we would need to open 10x or 100x connection and maintain them and flood the network with 10 to 100x. And it's just not scalable. So for now, it works, but we got to do better. And so you will find the complete report available at DQR Code that describe the full measurement methodology. I didn't go through all of the detail for time reasons. And we also have just more data and plots and some improvement recommendations. So there is the Move the Bytes working group that is working on, let's say, the next Bitswap. Here we have some recommendation to improve Bitswap. So that can serve of inspiration for future design protocols. And yeah, that was it for me.